Hello, my darlings. I will be giving you this lesson today by video. As you can see, we're going to be talking about two-dimensional shapes, and we're going to be talking about how they relate to the GED formula chart. So make sure you take out the GED formula chart that we've been using in class, and that way you can add to it, refer to it, whatever you need to do. Also, these notes will be taken in a color-coded manner, okay? And so I need you to make sure that you get a pack of colored pencils and you use the same color coding that I do. And that way there's a consistency throughout and we all kind of know what we're talking about, okay? Well, here we go. Okay, so the first shape we're going to talk about is a square. A square is interesting because it is a special type of rectangle, and that's where we oftentimes get confused. However, on the GED formula chart, it has some specific formulas just for the square, and so it often has caused some issues for some people. Just so you know, while we are going to specifically talk about the square here, you can use the rectangle formulas for the square. It won't hurt anything. But let's go ahead and talk about first the characteristics of a square, and second the formulas on the formula chart that deal with the square. So the first characteristic of a square is that all of its sides are congruent. And you'll notice that I denoted that with a little, oh goodness, hash mark or whatever you want to call it, a little line on each side, and they're in blue. So our color coding for this, anything dealing with sides, is going to be in blue, okay? And because each of them are exactly the same, we give only one mark on each side. If we have some different, then it'll be a little different, and I'll show you that coming up in a little bit. The second characteristic of a square is that all of the angles are right angles. They are 90-degree angles, okay? And so the way we denote that, you'll notice there's a red little square in the corner. And that's how you denote a right angle. You put that little square there, and that tells you, anytime you see that, then it is a right angle. All right? So make sure you're color coding and keeping up with everything we're doing up here. The third characteristic of a square is that its opposite sides are parallel. Now, one thing that you can note on here, okay, and let me see if I can grab a certain pointer to do this. Let me do a laser pointer so y'all can kind of see me. See, here I am. Okay, just follow along with me. You'll notice that the top side is parallel to the bottom side, and the left side is parallel to the right side, but that those sides are not parallel to each other. So the top side isn't parallel to the right side, and so on. And so the way you denote that, you'll notice that I have a little green arrow looking thing right here on the top, and then I have that same little green arrow thing looking thing on here on the bottom. Okay? And so they each have one because they are parallel to one another. The left and the right are also parallel, but not to the top and the bottom. And so we're going to put the same parallel symbols, except instead of putting one parallel symbol, we're going to put two, just like here. See, put two symbols. And so when you're doing this, all you have to do is look at the symbols. If you see these little arrows, even if they don't tell you explicitly in the question that it is parallel, those little arrows can tell you that. Just like the little hash marks can tell you that they're congruent, or the little squares can tell you that you have a right angle, okay? All right, let me get my regular stuff back. Uh-oh, there we go, now I do it. Wait. Arrow, there we go. Automatic, okay. Oh, it didn't go back to the arrow, hold on. Apparently I'm having a few technical difficulties. Visible arrow. There we go. Okay, so if you look on your formula chart, the two formulas that you're going to see that have to deal with the square are, under the area, it has A equals S squared, and under the perimeter / circumference, it has P equals 4S. Well, as these are, if we don't know what the variables mean, they don't really help us out much. And so that's the next thing we're going to talk about. Now, when I'm talking specifically in class, it's very rare that I will say A equals S squared, because like I said, unless we know exactly what that means or we're picturing it in our head, that doesn't mean a whole lot. And so let's talk about what each of these variables means, okay? That A right there, that stands for area. The S stands for side. And the little 2, that's in the exponent position stands for squared. Just as a quick reminder, s squared doesn't mean it's the side multiplied by 2. It means it's the side squared. So you've got the side times itself again. So side times side, okay? So if I were to say this in class, it would be area is the side squared, okay? If we go to the other formula, we've got perimeter is equal to 4 times the side. Remember, when they're hugging, they're right beside each other like that. That means multiplication, okay? And so what we're going to do now is, if you have any questions, of course, you can raise your hand. I might be in there. Someone else might be in there. I'm not sure. But, you know, if I'm in there, I can absolutely answer your questions. If it's someone else that knows their math, they might be able to answer too, because most people have used this for a long time. If they can't answer, just write it down, okay, and then put a little star beside it to remind me, you know, if I'm gone, put a little star beside it to remind me when I get back that you've got a question about that, okay? So at this point, please make sure that all of this is written down and give me a little wave, or whoever's in the classroom, a little wave if you need to pause so you can get it down, okay? Okay, if everyone's finished now, we're going to move forward. The next one we're going to look at is a rectangle. You'll notice it's kind of like a square, except that it's not. It's longer on the top and the bottom. You could also have it to where it's taller instead of longer. That's fine. Okay. Unlike the square, we do not have all sides congruent. Instead, we have opposite sides that are congruent. And you'll notice that just like before, when we had the parallel symbols, and then we had one on one set of parallel sides, and then two on on the second set of parallel sides, you can do the same thing with your congruent symbols. Okay, you've got two of them on the top and bottom because those two are congruent, and then one each on the left and the right because those are congruent. And so all of that works just fine. And you guys can kind of see how it goes, okay? And so opposite sides are congruent. Now make sure you're getting all of this down in your notes, color-coded just the way I have it. Okay, here we go. All angles, just like in the square, are 90 degrees. They're all right angles. And so just like the square, they're going to have the little squares in each corner. Oftentimes they'll be in red, but not always. You just remember, if you see a square in a corner, that is a 90-degree angle. And then opposite sides are parallel. That also is just like the square, okay? You've got the top and the bottom that are parallel, and then the left and the right are parallel. A frequent question asked is, does it matter which one has the 1 and which one has the 2? And the answer to that is it actually doesn't. It does not make one bit of difference. If you had 2 of them on top and bottom and one of them on the left and right, that would be just fine. Or even if you had, you know, 5 on the top and bottom and 3 on the left and right, that's fine. A little unnecessary. Just the whole key is to make sure that whichever lines are parallel, they've got the same number of marks, and that way you know which ones go together. So it doesn't really matter which ones you pick to have 1, which ones you pick to have 2, and so on. Okay, so now let's look at the formulas that are on the GED formula chart for the rectangle, okay? You should find 2 formulas on there for it. You should find area equal, under the area you'll have A equals LW, and under perimeter you'll have P equals 2L plus 2W. Now, another frequently asked question is whether it matters which one's the length and which one's the width. And honestly, it doesn't. You can make it either way, but the generally accepted way to do it is if your top and your bottom are your length and your left and your right are your width. And excuse my messy handwriting. This is me writing with my mouse, and so it's going to be kind of messy. But you guys can see what's going on here. You've got the length on the bottom, the width on the side, and that's generally what's going to happen. And so these are probably one of the most common ones you guys have used as you go through school, elementary, middle, and high school. We use these ones quite a lot. And so we'll probably know what they mean, but that's okay. We'll go through it anyway. We know that A stands for area, okay? L stands for length, and W stands for width. And because the L and the W are hugging, remember, anytime we see numbers that are hugging, or variables that are hugging, or maybe a combination of numbers and variables that are hugging, it means that they're being multiplied. If there's nothing between them, That means multiplication. And then we've got our perimeter, okay? And our perimeter is equal to 2 times our length plus 2 times our width. Now, a question that was asked of me was, is this different from adding all 4 sides together? And the answer is no, it's not. It's actually exactly the same as adding all 4 sides together. It's just a formula to help you remember in case you forget. If you're more comfortable with just, finding out what all 4 sides are, slapping them together with a sum and then just moving forward, I would say go with that. That's not a big deal. Again, I'm going to make sure to comment, make sure you have all of this onto your notes, okay, every bit apart. Make sure that you have the color coding for the blue, the red, and the green, just the way I have it. That way you can have your notes look just like this, and I can help you in the future, and it's going to help us all be on the same page, okay? So if you need a little more time to get this down, give me a little wave, and I will pause it, and we'll move forward after that. All right, our next shape is a rhombus, which I call a squished square, okay? The reason I call it a squished square is because it does have some of the characteristics of a square, all right? It does have all sides congruent, and so just like a square, all 4 of these sides are exactly the same. Where it starts to differ is in the angles, because you'll notice that over here there is not a right angle right here, okay? And there's not a right angle right here, or right here. And if we look at the reality of it in the definition of it, a square is a special kind of rhombus, okay? But a rhombus is usually more slanted when you see them. And so they look like this. Now, whoop, that's not what I wanted. Give it back. All right. And so our rhombus has this type of shape. And so all sides are congruent, but opposite angles are congruent. Not all of them. They're not all 90 degrees, but if you'll notice, this one down here, that's acute. The one up here in the corner, that's also acute. This one over here, that one's obtuse, and the one across from it is also obtuse. Now, as such, there's another characteristic that we have not considered yet. It is true for the square and the rectangle, it's just not something we normally write down. And that is that adjacent angles are supplementary. And here's what that means. An adjacent angle is there are a pair of angles that are next to one another. So like this angle right here and this angle right here, those are next to each other. You'll notice one is acute, the other is obtuse. Those two are supplementary. If you were to add them together, whatever they may be, then they are going to equal 180 degrees when you do that, okay? You'll also notice we could go all the way around this way. This angle right here and this angle right here, those are adjacent. They're next to one another, and they are also supplementary. This one plus that one would equal 180 degrees. And it's true for all the angles all the way around the rhombus. And so when they only give you one angle and you need to find the others, it's a pretty handy way to allow you to do that. All right, let's take a look. And just like the other shapes we've already talked about, our opposite sides are parallel. And so you'll notice that we have the same markings there. Okay? Now, there are no formulas on the formula chart that deal with rhombuses, but that doesn't mean that we won't come up with them or they won't pop up in a problem. And so what happens is, when you see a rhombus, you need to use the formulas for a parallelogram. A very common mistake, since all the sides of a rhombus are congruent, is that people will use the square formulas to handle a rhombus, but it actually doesn't work. You have to use the parallelogram formulas, okay? So if you see a rhombus, use the formulas for parallelogram. Make sure you have this down. If you don't have it, give me a little wave, and then we will move forward once everyone is ready. Okay, At this point, I'm going to take a little media break. I don't know what you want to call it. Because from this point on in this video, you guys are going to do something in the classroom. Whether I'm in there or whether someone else is in there, I still want you to do this, okay? And you may seem silly at first, or it may seem silly. You may feel really silly doing it, but promise you it works, especially when we're trying to learn this particular vocabulary word. You'll notice that at the top of the page it says perpendicular. And so what I want you to do is every time you see this word perpendicular, I want you to give me a big old thumbs up and say right on, just like this guy right here, okay? Give a big thumbs up and say right on. We do that for a couple of reasons, because our thumb and our hand, kind of, if we can do it right, not all of us can bend our thumbs that way, make what looks very close to a right angle. Also, we are relating the word right in right on to the word perpendicular. And a set of perpendicular lines cross or intersect to make a right angle. And so it's helping us kind of put those two things together. And remember that anytime we have perpendicular, we have something that's right or 90 degrees, okay? So let's try this one more time. Let's see what we're doing. Remember, I say perpendicular, you say right on. Are you ready? Perpendicular. Did you say it? These guys said it. Do you see that? They have all their thumbs up down there. Did you do that? Like this, guys? Did you? Okay, well, we're going to try it 2 more times. And both times, whoever's in the classroom, make sure they're doing it, okay? Ready? Perpendicular. Perpendicular. All right. Well, hopefully you've kind of gotten the idea and you've gotten your right on. Okay, so anytime I say this word from the rest of the video, if I say the word perpendicular, I'm going to pause, and I'm hoping that you're going to say right on in the classroom. And if you don't, well, then it's a silly little pause, and, well, you'll make my heart sad, okay? And so let's just try to do the perpendicular right on thing. It really does work. It's kind of fun, and it makes other people look at us funny, which, might make them smile, and so it's always a good thing. So now let's look at parallelograms. I told you that rhombuses were squished squares, and now a parallelogram is a squished rectangle. It's like someone took a rectangle and they kind of pushed it over and squished it a little bit. All right, and so it's got some traits that are similar to rectangles, and it's got some traits that are similar to rhombuses, and so you're going to kind of see where that comes in, okay? Our first trait, and this is in blue because it is about the side lengths, okay? Our first trait is that opposite sides are congruent. You'll notice that this is just like a rectangle, okay? Our opposite sides go together. This time I have the left and the right having one little mark, and then the top and the bottom having 2 little marks. And that's perfectly fine. We don't mind either way. It can be, flipped. It doesn't matter as long as you put the ones together that go together. The opposite angles are congruent, and this is what we saw in the rhombus. And so, we're just kind of trucking things along and making things work here. Okay, so our opposite angles are congruent, and also, just like the rhombus, our adjacent angles are supplementary, which means their sum is 180. So just like before, if we have 2 angles that are adjacent, let's see if we can't remember what adjacent is. Someone in the classroom, tell this video what adjacent is. Okay, hopefully someone said that adjacent is next to, because that's what it is, okay? Adjacent means next to. Opposite, of course, is opposite, and adjacent is next to. And so we've got this one and this one. They're next to each other, therefore they're supplementary. Same thing over here, this one and this one, supplementary. This one and that one, supplementary. Supplementary is a fun word to say. If you're not used to saying it, just try it out. Supplementary. 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 They're very fun. I like the word supplementary. And then, like every shape we've talked about so far, the opposite sides are parallel. Believe it or not, eventually we are going to get away from that. Okay? Now, when it comes to a parallelogram, we have a hard time figuring out how to work the formulas on the formula chart often. It's not because it's not, I don't know, I was going to say it's not because we just don't know how to do it, but we kind of don't. We're so used to doing rectangles that we don't see parallelograms and rhombuses very often. Or I guess, would it be rhombusi? Rhombi? Elvis, Elvi, anyway, who knows? Cactus, cacti. Maybe it would be rhombi. Radius, radii. I don't know. Anyway, when we see a parallelogram or a rhombus, I'll just leave it shortened, and that way I don't have to worry about it. Then we can use these formulas, but here's where they come in handy, okay? The formula over here, we know that A is area, B is base, and H is height, but here's the mistake that people usually make, okay? They know that either the top or the bottom is the base, like that. Oh my goodness, that is a square B, but you get the point. But a lot of people come over here and they make this side the height, but that's not the height, okay? That is just another side. The height is actually through the middle of the shape, and it's right here. And the height will always make a right angle with the base. Therefore, the height and the base are always perpendicular. Did you remember to do the right on? Let's try it again, just in case. The base and the height are always perpendicular. Okay, and this will be for every shape that we come across. Base and height are always perpendicular. I almost forgot to pause on that one. All right, and so no matter what shape we come across, that's going to be true. Okay, so when you're looking at this, just be careful to know which sides to use. Now, it also says there's no formula for the perimeter. Just use, or just add all the sides, but do not include the height. So even if you have this right here, you don't include that when you're doing perimeter. Because with a perimeter, it's like you're walking around the outside of the shape. And so you're going this way, then this way, then this way, and then this way. And the height doesn't matter one bit, okay? You don't care what it is. And so you just kind of go around the shape however it needs to go, and you ignore the height when you're working on perimeter, okay? And that's how this particular story goes. And so while I'm erasing the ink on my slide, I'm going to remind you that you need to write this down, okay? So if you have not yet written it down, please get it down as quickly as possible. Give me a little wave if you need some time, okay? Okay, now hopefully everyone has gotten all 4 shapes we've done so far. Just if you need a quick reminder, if you need to kind of double check that you have everything that we're supposed to have, we've done a square, we've done a rectangle, we've done a rhombus, and now we've done a parallelogram. And so now we're going to jump out into some other two-dimensional shapes that have different relationships with the sides around them. And so we're not going to be seeing all of these same things over and over anymore. We've kind of covered those bases. And so the next one we're going to talk about is a trapezoid. Okay? A trapezoid is a four-sided shape, and so it's still a quadrilateral, but it's different because unlike all the other ones we've done, it's not a parallelogram, okay? A parallelogram is classified as anything that has 2 pairs of parallel sides. Well, this one doesn't. It's only got 1 pair of parallel sides, and those parallel sides are called the bases, okay? This is going to come in handy with something else that we do, so I'm going to go ahead and write it down for you. So let's say we label this base 1, and then we'll label this one up here base 2. It actually doesn't matter which one you label which. It can be either way, okay? This could be base 1 and that can be base 2. It really doesn't matter. I tend to, out of an odd habit, just always make the larger one base 1, and I'm not sure what habit that is because we don't ever subtract them normally unless we're looking for an odd side length on whatever side. But okay, so here's some things you need to know about trapezoids. Okay, some of them look like this. This happens to be what's called an isosceles trapezoid. It means that this leg right here and this leg over here, the leg on the left and the leg on the right, are the same length, but that's not always the case, and so I'm not going to add that to my picture here, okay? If it was the general rule, then I would add it, but I'm not going to add that to my picture here because it's not always true. The bases are always parallel, but these sides over here aren't always the same. When the 2 legs over here are the same, that's called an isosceles trapezoid, just like an isosceles triangle, okay? There can also be what's called a right angle trapezoid, where one of the sides on the left or the right comes down in a right angle, so you end up with two right angles on this side, and then these other sides make whatever angle they're going to. Again, it is an exception and not the rule, and so I'm not going to put that on here for the PowerPoint. It's just something that I want you to be aware of in case it pops up. So you can have right trapezoids and you can have isosceles trapezoids, or you can have these more scalene type trapezoids where nothing is the same length, okay? All right. So for a trapezoid, there's no formula for perimeter. So you're just going to add all the sides together. Again, just like in the last one we looked at, that does not include the height. Okay, remember, for perimeter, you're kind of taking a walk around the outside of it. And so you're not going to cut through the center because that's cheating. You're going to take a walk all the way around the outside. Consider you to be racing one of your friends or something. And then the area formula is there, however, and here's what it looks like. And it looks pretty complicated, but I promise it's not that bad. All right. And so we have A means, of course, area. H stands for the height. B1 means base 1. And B2 means base 2. Notice how they're both being added together, so we don't really care which one is base 1 and which one is base 2. 3 plus 5 is the same thing as 5 plus 3. You'll still get 8 no matter what. And so it doesn't matter what you're doing. Now, I do want to comment briefly about this 1/2 that's in the front. And I'm going to tell you that I have some people that seriously freak out anytime they see something like that. They're like, oh my gosh, what does that mean? I'll tell you. And the biggest question they have is, okay, do I multiply by 1/2 or do I divide by 2? I'm so confused. And I'm going to tell you, the reason it's confusing is because it's either one. It actually is multiplying by 1/2 or dividing by 2. Don't do both of them, but either one will give you the correct answer, okay? And so anytime you're looking at something like that, just realize that you can do that, okay? All right, so again, make sure this is written on your notes. If you need a little bit more time, give me a little wave, and then we will move forward. Oh, I forgot to change my arrow. There we go. Okay, triangles are complicated. Why? Because there are so many different kinds. There are quite literally 3 ways to classify it with angles and 3 ways to classify it using sides. And every triangle has both a side and an angle classification. So I've got a couple examples for you. Okay, here's some right here. This triangle over here, this one, is called a scalene triangle. It is also equilateral. I made it all the same size. Or did I? No, I made it as, yeah, I think it's equilateral. So I have an equilateral acute triangle here. This right here is, I tried to make it isosceles, but I may not have made it work. This is called a right triangle because it has one right angle. Notice not all 3 angles could be right angles because otherwise it wouldn't work, but one angle can be a right angle, and so that's this one. And then these other 2 angles make up the rest of the triangle. And so I tried to make this as scalene as I could, where this leg right here is the same length as this leg. But I'm not sure quite if I accomplished that. This over here is a scalene obtuse triangle. So I tried to cover all the different triangles we could run into. We've got a big old obtuse angle right here. And notice only one angle is obtuse, the other 2 are acute. It only takes one angle to be different to label it as something else. And then all of the sides are different lengths. So that one is obtuse scalene. This one is right isosceles, and this one is equilateral acute. Okay, and so they can get a little confusing because there's so many things that could happen with them, but luckily we use the same formulas for everything. And so here's the formulas we have to use. Now, of course, with the different triangles, the formulas seem to be a little different. I'm going to say for your this formula over here, we've got A, of course, is area, equals 1/2. Remember, that could mean multiplying by 2, or multiplying by 1/2, or dividing by 2. Then we've got our base and our height. Okay, and in each of these, those are in different places. And so let me show you where they are. And you will definitely want to write these down. Okay, right here, that's my, oh, that is not my base. What am I doing? Okay, hold on. I got writing happy. Okay. Here we go. This is my height right here. It goes straight up and down, and it is always perpendicular to the base. Did you do it? I hope so. The height is always perpendicular to the base. Okay, so height perpendicular to base. Same thing here, but in a right triangle, since these two sides are already perpendicular, right on. Just making sure you remembered. Our base and our height are actually given to us right in front of us. This is our base, and this is our height. We don't have to look for anything extra. They're right there on the outside. This obtuse triangle looks very much like this acute triangle. Our height has to be on the inside, so it can be perpendicular to the base. And so there I make my right angle right there, and I put my base right down here and make it perpendicular to my height. Okay, and so that's where these things go. You'll notice that the perimeter is pretty quick and easy. The perimeter itself is just like everything else. It's just adding all the sides. And so we've got our perimeter is equal to our side 1 plus our side 2 plus our side 3. Because we're adding everything, it doesn't matter which side we pick to be 1, 2, and 3, as long as we just put everything all together. I'm going to clear off my ink because I'm kind of running into some of this stuff. There we go. And I'm going to remind you to make sure you have everything from here on your notes. Okay, giving you a little wave if you need a little more time so you can get it down. I will point out too that you should notice that on this particular one we did not make any marks for congruence or for parallelism or for angles. So here's what you should know about a triangle. Okay, I'm going to try to get this in here because I should have written it in and I completely forgot. Okay, here we go. Okay, so for a triangle, what you should know is that the sum of all angles is 180 degrees. And so if you were to add up all three angles on any triangle, you would get the sum to be 180 degrees. My goodness, my handwriting is bad with my mouse, isn't it? Okay, so my sum is 180 degrees. What you should also know, okay, is that on this triangle right here, remember this one was the one I tried to make equilateral. That means I could put my little 1 hash mark on each side, and those are going to be the same. And also, if I have an equilateral triangle, my angles are going to be the same. So they're going to have that little curvy line right there. They'll each be 60 degrees, okay? So when I'm looking at an equilateral triangle, my sides are all the same and my angles are all the same. If you remember the video from Friday for the classes that got to watch it, that's called a regular shape, okay? When you've got all sides and all angles equal, they call that regular, okay? And I know it's an odd thing to call it, but that's what they do. For this scalene triangle over here, I'm sorry, not the scalene, the isosceles triangle right here, that means that this side and this side are going to be the same, okay? Since it is a right triangle, I've got a right angle mark right there, and I tried to do the best I can to make my little square right there, all right? And just to make it even more tricky, if this is isosceles, then these two angles over here are also equal. But if it's not isosceles, then that's not true. Because over here in this one, nothing's the same. So I can't mark a scalene triangle at all. And so an equilateral triangle will have several marks. It'll have side marks and it'll have angle marks. A right triangle will at least have the side mark, well, the side marks if it's isosceles, but it will at least have that little red square right there. If it is an isosceles, it will have the side marks and the other angle marks, but if it's not, those will not be there. Okay, so I just want to make sure we covered that really fast. Okay, circle. This is the last two-dimensional shape we are going to cover. All right, and so the things that I want you to see are this long one right here. That is called a diameter. And what I wanted to show you, because it's kind of nifty, is that if you've got a diameter, okay, if you trace over it and trace over a part of the circle, it literally gives you a D for diameter. You kind of have to ignore the rest, and you have to ignore my messy handwriting, but it gives you a D for diameter. And so it helps remind you that the one that goes all the way across is a diameter. If you want to look at a radius, that can do the same thing actually. This one over here goes from the center to the outside. Remember that a radius can go any direction. It can go up, or it can go left, or it can go down, or it can go right like it goes here. And so if you think of a radius that's going like from the bottom to the top like this, look, that can make an R for radius, okay? And so remember that a diameter will make a D, and a radius will make an R, and that'll kind of help you remember which one's which if you have trouble with that. Something you also need to know, and I actually have it written on the board to your left, it should be up there, is that the diameter is twice the length of the radius, or the radius is half of the diameter. So for example, if I had a diameter of 10, the corresponding circle would have a radius of 5, okay? If I had, let's see, if I had instead a diameter of, oh, I don't know, 8, okay, my radius would be 4. So just to kind of give you a little bit of context, okay? If I had a radius of 20, what would my diameter be? My diameter should be 40. How many of you said 10? I'll bet some of you did. Remember that even if the number is big, you have to, it depends which direction you're going as to what's going to happen with the numbers, okay? So just keep that in mind. When we're looking at our circles, okay, we have a couple of things on that formula chart. The first thing we have under perimeter/circumference is this big old long thing. And it's kind of confusing, and so I'm going to show you how to deal with it. First off, ignore the or, and don't